Hello friends, in this video we are going to see design of one-way slab in limit state method. Question is, design one-way slab for following data: size 3 meter into 9 meter, width of support is 230 mm, live load 3 kN per meter square, floor finish 1 kN per meter square, use M20 and FE415. First step is finding type of slab. LY is long span 9 meter, LX is short span 3 meter. Formula for calculating type of slab is LY by LX. So the answer is 3, which is greater than 2. So it is one-way slab. Next step is calculating dimensions. We must calculate effective depth, overall depth, effective span and breadth. Effective depth formula is short span by 25. So effective depth answer is 120 mm. Overall depth formula is effective depth plus D dash. D dash is clear cover for slab 30. So overall depth answer is 150 mm. Next step is effective span. Effective span formula is Lx plus support width or Lx plus D. So calculating in those two formulas, whichever is lesser answer, we take it as effective span. This is given in IS456 2000, page number 34. Here in effective span, simply supported beam or slab, the effective span of a member that is not built integrally with its support shall be taken as clear span plus the effective depth of slab or beam or center to center support, whichever is less. According to this, we calculate effective span. Here 3.12 meter is lesser, we take this as effective span, and breadth of slab is always 1000 mm, assumed as 1000 mm. Next step is load calculation. Self weight equal to breadth into overall depth into 25. Live load and floor finish is given in the question, so load answer is 7.75. Now we must calculate ultimate load. Ultimate load is 1.5 into load. Answer is 11.625 kN per meter square. Next step is ultimate moment and shear force. Ultimate moment formula is WU into effective span by 8. WU is 11.625. Effective span square is 3.12 square by 8. Answer is 14.15 kN meter. Next is ultimate shear force. Formula is ultimate load into effective span by 2. Answer is 18.135 kN. Next step is ultimate limiting moment. Formula for ultimate limiting moment is 0.138 FCK BD square for FE415. In question they have given FE415, so the formula is 0.138 FCK BD square. If they have given 250, formula is 0.148 FCK BD square, and for 500, 0.133 FCK BD square. Here ultimate limiting moment answer is 39.74, which is greater than ultimate moment. Next step is main reinforcement. Main reinforcement formula is in IS456 2000, page number 96. Formula is 0.87 Fy AST into effective depth into 1 minus AST into Fy by FCK into breadth into effective depth. Calculating in this formula, we get AST answer 347.46 mm square. Small AST formula is pi d square by 4. D is 12 mm dia. Answer is 113.097 mm square. Spacing formula is AST, small AST by AST into 1000. Answer is 325.5 mm. Rounding it, we get 350 mm. In main reinforcement, we provide 12 mm dia bars at spacing 350 mm center to center. Next step is finding distributed reinforcement. Spacing formula is small AST by AST into 1000. AST formula is 0.12% into breadth into overall depth. Answer is 180 mm. Small AST formula is pi d square by 4. D is 10 mm. Answer is 78.54. Calculating in this spacing formula, we get 436.3. Rounding it, 440 mm. In distributory reinforcement, we provide 10 mm of bars at spacing 440 mm center to center. Next step is check for shear force. This is to find tau v and tau c value. Tau v formula is in IS456 page number 72. Ultimate shear force by breadth into effective depth. Answer is 0.15 Newton per mm square. Next is K into tau c. K value is in IS456 page number 72. Tau c is calculated by percentage equal to AST by breadth into effective depth into 100. Answer for percentage is 0.09, which is less than 0.15. Referring to the table in IS456 2000 page number 73, we get tau c value as 0.28. So K tau c value is 0.36 Newton per mm square. So tau v is less than K tau c, hence safe. Next step is check for deflection. Here L by D basic for slab is 25. L by D actual is effective span by effective depth. Whatever we have calculated, and the answer is 26. L by D formula is L by D basic into KT into KC into KF. KT, KC, KF value is in IS456 page number 38 figure 4. Referring to it, we get 1.2. Calculating in a L by D max formula, we get 30 as answer, which is greater than L by D actual. Hence, design is safe. Next is one-way slab diagram. This is 12 mm spacing of 350 mm center to center is main reinforcement. 10 mm spacing at 440 mm center to center is distributory. This is effective depth, and overall depth is 150 mm. This is design of one-way slab in limit state method.